Welcome back, student, to section 11.4. Today we will talk about the comparison test. Comparison test, it will remind you of something we did already in section 7.8. So you can pause the video now, go back to section 7.8, study again the comparison test that we did for the improper integral. It will make it easier for you when we deal with series. Now, what's the comparison test? I will give you a series. So given a series an, and now we want to test whether this is converge or diverge. So what we will do, we will compare it with another series. Of course, when we say another series, we mean maybe simpler and well known. So we know if it is converge or we know if it is diverge. So we compare something that we know the type of behavior. And based on the comparison, we have these two rules. The first rule, if an is less than bn and bn as a series converges, so if the big one is converges, the small one converges. That's if we are lucky, we find a series which is larger and converges, then the small one also converges. Now the opposite way. What happened if bn is the smaller and we know that bn diverges? So the small one is infinity, the large one will be definitely infinity. So we have the first one converges, the second one diverges. Okay, that's the beginning of this section. And now let's see an example. So we have example number 1. The first series we will see today is 1 over n cubed plus 8. Now, the idea is we use the comparison test. Comparison test. So you have to compare your series with something simpler, something very simple, because if it's simple, we will know what is it. If you remember, if you use the same idea we did in the improper integral, we have to compare with the largest power of n in the numerator, which is nothing, and the highest power of n in the denominator, which is n cubed. Now ask yourself, do we know if this is converge or diverge? Do we know that? Let's look only at this one. So I will take you to a side here. Okay. And I will ask you, this series converge or diverge and why? Before I do anything, let me test if I know this one or not. The answer is converge. By which test? The b-test, with the power of n is 3 greater than 1. So it is converges. Okay. Now you might check which one is larger. Maybe you just can throw numbers like n equal 10, 20, 100 and see which one is greater. Or you can play with it. If you just multiply this by this, so let me just do it here in a side. If we just do the multiplication, we get n cubed, and on this side we get n cubed plus 8. If we cancel n cubed, we get 1. We get 0 compared to 8. Now, which one is larger? Of course, the 8 is larger. So this is larger, and this is larger. Now, if the big one is converges, now we find that this is the big one, the bigger one, and it is converges. So what can you say about the small one? Of course, it's converges. And that's what we will write here. by the comparison test. Converges. Okay, that's the comparison test. We can use this test, especially if we have sine and we have cosine. This test will be a very, very useful and very, very nice test. Shall we see such an example of something with cosine and sine? I'll just have an example, give you the idea. That's what we will do next. This example of sine and cosine, so this is example number 2. Take the series, for example. Again, we need to compare this one into something that we already know. First of all, compare for me the sine. What do you know about the sine? The sine usually it's between -1 and 1. If we have square, this will ensure it is positive. So it is between 0 and 1. So we can just take the sine out of the equation of everything, and we just write in here. The denominator is just the denominator. And that's what we have up here. Okay. The next step is we just compare it with n cube, sorry. So this is 1 over n square, and then you have to compare them. It will be the sine. Try it at home and let me know if this is the correct one and the series gonna converge. The next one will be the limit comparison test.